Thank you so much to the organizers for organizing this important seminar series and also for the opportunity for me to speak here today. So I would just like to mention before I start my presentation, this is not a project, but rather a discussion from which fellows and colleagues can draw ideas from and perhaps produce into postgraduate projects. So let me start by saying Dumelang, Molo, Huitahani, Sawubona. Good morning to all of you present today. Thank you so much for attending. Ladies and gentlemen, dear esteemed colleagues, it is with great pleasure to be here with you today to explore a topic that is deeply connected to the nature of African, or the future rather, of African agriculture, the intersection of African epistemologies and nanotechnology within sustainable agriculture. So today I will be going to delve into the rich conversation about how traditional African knowledge systems, when combined with modern technological innovations, can create a transformative impact on agriculture in Africa and also the rest of the world. This conversation is not just about blending the evolving with the new, but also about creating systems that are resilient, culturally relevant, and environmentally sustainable. So, throughout this presentation, I will take you on a journey through African epistemologies and nanotechnology, outlining some of the following. I will be briefly discussing an overview of African epistemologies within the context of agriculture. Since we are a multidisciplinary audience, I will also try to explain to you the principles of non-nanotechnology and how that can be applied to agriculture. What is sustainable agriculture, traditional agricultural practices within Africa, innovations in nanotechnology for agriculture, some case examples, cultural perspectives in technology adoption, ethical considerations in nanotechnology, which is very important, the integration of indigenous knowledge and technologies, benefits of combining these epistemologies with nanotechnologies, the challenges in implementation, which is also very important, policy frameworks for sustainable innovation, collaborative research models, the impact that this can have on food security, and also potentially the environment, the economic implications for farmers, educational initiatives, which is also very important, community engagement, technological accessibility and equity in this endeavor, future research directions, and the role of various stakeholders, including cross-disciplinary collaborations. Now, these topics kind of combined offer insights into how these approaches can be integrated to tackle food security and sustainability challenges. So, moving a bit to the digital technologies, I will not extensively address this in this presentation, but this can also allow for innovation in traditional practices, such as integrating indigenous agricultural techniques with modern scientific approaches to create more sustainable solutions for issues such as food security and environmental management. Collaborative platforms such as artificial intelligence and big data analytics can all be used to enhance indigenous resource management strategies, from, for example, land use to climate resilience, blending traditional ecological knowledge with contemporary technologies such as nanotechnologies. But first, let us look at the overview of African epistemologies within the context of agriculture, and then also some other definitions for nanotechnology, sustainable agriculture, etc. So let's first begin by defining what we mean by African epistemologies in agriculture. In simple terms, this refers to indigenous or African ways of knowing, how knowledge is created, shared, and applied in the various African cultures. And unlike Western epistemologies, which often focus on the compartmentalized, reductionist methods of inquiry, African or indigenous epistemologies emphasize holistic, interconnected, and very importantly, community-based approaches to knowledge. In this context of agriculture, this is particularly important because African farmers have for centuries used methods that are deeply rooted in their understanding of ecosystems, biodiversity, and the relationship between humans and the natural environment. So, for example, in many African cultures, knowledge about the land and how to grow food is passed down orally through generations. It's embedded in cultural practices, in rituals, and in community storytelling. This type of knowledge, is not just about farming techniques. sorry, it also encompasses a spiritual connection to the land, which is often considered sacred. In some regions, people also believe that their ancestors inhabit the land and guide them in managing it sustainably. Now, another very important aspect is holism. This is another key principle in African epistemologies. When African farmers approach farming, they do not simply think about crops in isolation. They also consider the soil, the water, the biodiversity around them, and even the weather patterns. So this kind of thinking is incredibly relevant today as we look for ways to practice agriculture that does not damage the environment or degrade the soil for future generations, and especially during a time of climate change. So let us now move on to nanotechnology. So for those unfamiliar, nanotechnology involves manipulating materials at an incredibly small scale, what we call the nanoscale, where properties can change and open up new possibilities for different applications and even in agriculture. This technology operates at the level of molecules and atoms, which means it can offer highly precise solutions to agricultural challenges. Now, as we all know, agriculture is facing numerous and unprecedented challenges that present a threat to sustainable food security. Abiotic and biotic stresses, including climate change, environmental pollution, urbanizations, wars, pests, and diseases are significantly affecting crop yield and a sustainable food supply via multidimensional avenues. Furthermore, the unsustainable use of pesticides and fertilizers, also multi-nutrient deficiencies in soil or low nutrient use efficiency, combined with the augmented application of chemical and organic fertilizers. These factors are all systematically degrading natural resources and causing eutrophication of water and soil bodies. Now, interestingly, with traditional fertilizers, up to 40 to 70% of nitrogen and 80 to 90% of phosphorus, and even 50 to 90% of potassium may be lost in the environment due to nutrient runoff, nutrient immobilization, or even poor nutrient use efficiency by plants. And by the year 2030, the demand for these agricultural products, especially fertilizers and pesticides, it will have to increase by almost 60% to sustain the health and well-being of a rapidly expanding population, estimated to reach 8.6 billion by 2030. So alternative approaches to boost this agricultural crop performance is urgently warranted. And such solutions should ideally deviate from the unsustainable model of just increasing fertilizer input doses that are also leading to the depletion of natural resources. So to find solutions to this current crisis within the agro-production sector, nanotechnology have been suggested as a novel and innovative technology. And benefits of these type of fertilizers include the use of smaller quantities, hence reducing transport and application costs, the provision of smart nutrition due to its targeted and slow release kinetics that could be synchronized with crop nutritional needs, and also its higher nutrient bioavailability, absorption, and mass transfer capacity due to its small sizes, high surface to volume ratios, and increased ionizing power. Now, another interesting and very promising innovation in this type of nanotech applied to agriculture field is nanosensors. And these are basically tiny devices that can monitor the health of crops and the condition of the soil in real time. So just imagine being able to measure soil moisture levels or detect early signs of disease or nutrient deficiency in your crop without waiting for the actual visible symptoms. Now, nanosensors make precision agriculture possible on a scale we have never seen before. And then lastly, let's not forget about our nanopesticides, which can target pests more effectively while minimizing harm or to non-target species and reducing the need for chemical applications that can have damaging long-term environmental but also health impacts. So let's look at sustainable agriculture. So at its core, it's about balancing the need for food production with the preservation of environmental, economic, and also social health. The goal is to meet today's food needs without compromising the ability of future generations to meet their own. So this is an area where African epistemologies combined with nanotechnologies can complement each other very beautifully. And sustainability in agriculture often revolves around the three pillars: the environmental sustainability, again, your economic sustainability, and then once more, your social sustainability. So let's break these down a bit. So when I refer to environmental sustainability, we want to reduce chemical inputs, we want to conserve water and maintain biodiversity. Now with nanotechnology, for example, nanofertilizers, these can all be achieved. So it's about farming essentially in a way that protects the health of the land for the future. Let's look now at economic sustainability. It means making farming more profitable, and in many African contexts, this is especially challenging for smallholder farmers who have limited access to resources. Let's move now to social sustainability, and this ensures that the benefits of the agriculture are shared equitably, promoting both the health of your environment, your communities, and increasing food security. Now, nanotechnology combined with African epistemologies can all support these pillars by providing the tools that improve the efficiency of the agriculture, reduce waste. For example, if one uses green materials produced by the farm to manufacture nanofertilizers, this can help reduce waste, which also contributes to pollution and to climate change. And this can also enhance resilience in agricultural systems. So again, African epistemologies, on the other hand, can contribute to a deeper understanding of ecosystems, long-standing farming techniques, and community-based decision-making processes. And this all play a very, very vital role in sustaining the agricultural landscape. So let's delve a little bit deeper in traditional agricultural practices in Africa. So it's important to understand, first of all, before you start research on nanofertilizers or nanotechnologies in agriculture, to understand the traditional agricultural practices in Africa and to try and complement that. So these basically form the bedrock of African farming. So for centuries, as we all know, African farmers have employed sustainable techniques that are both ecologically and culturally adapted to their specific environments. And here I can show a few examples. For example, in West Africa, intercropping and agroforestry have been practiced for generations. And intercropping is basically the cultivation of two or more crops in proximity. And this has been shown basically to reduce pests and diseases. And it also enhances the biodiversity and also soil fertility. By integrating trees and shrubs and other types of plants into their farming systems, African farmers not only improve soil fertility, but also create habitats for wildlife, and also this practice also reduces erosion. So in Southern Africa, water conservation techniques such as rainwater harvesting and terracing are also critical, especially in arid and semi-arid regions. And these practices allow farmers to capture and store water, reducing their dependence on unpredictable rainfall patterns. Now, if we think about East Africa, the use of organic fertilizers such as compost and manure has also been long practiced to enrich soils and promote sustainable farming. And these organic fertilizers improve soil structure, enhance the water retention, and encourage microbial activity in the soil that can also help complement nano fertilizers that basically does the same thing. So these practices are inherently sustainable and aligned with the principles of ecological health. However, many African farmers face new challenges due to climate change, also population growth, also children leaving the farm to go and work in the cities, and the increased pressure on natural resources. So this is where nanotechnology can come in, providing the tools that can help build on these traditional practices while also enhancing productivity and resilience. Now, as I have already highlighted, there's the various innovations in the nanotech sector for agriculture, the nanofertilizers we already touched on, and these can be designed, as I already mentioned, to increase the efficiency of nutrient delivery. It normally, like I mentioned before, with traditional fertilizers, you have a lot of leaching and volatilization and loss of nutrient use efficiency. While nanofertilizers, you can apply less amounts, you can apply to the leaves, to the soil, or a more targeted approach would be to just apply directly to the seeds. And studies have shown, depending on your type of nanofertilizer and the manner of synthesis, that this can significantly up to 50% increase your crop yields. Now, nanopesticides is also another important aspect of the nanotech industry, and then nanosensors as well. So let's look at a potential dummy sample of how nanotechnology can help African agriculture. So it can be used to help soil and water management, okay? It can improve the soil quality and the water retention, and this can be particularly important for arid regions. It can help with pest and disease control, and also you can design certain nanoparticles made up of some metals or some other compounds that can serve as antimicrobial agents also that can also help control plant diseases like fusarium, root rot, etc. Of course, nutrient delivery is also important. We want efficient nutrient delivery so that we can have enhanced crop yields. And we want to couple that with our environmental benefits, no nutrient runoff, improved soil health, and also there's also been some research that showed that these nanofertilizers can also improve the health of soil microbes, and especially soil microbes that are used to boost plant growth, such as mycorrhizal fungi. Now, as with all technologies, there remain some challenges and future directions for this. Access and affordability is always a challenge. Ensuring equitable access to nanotechnology is important. Much more research and development in this field is required, especially toxicology testing. How does nanofertilizers affect the environment? Other flora, other fauna, where does it all end up? Does it accumulate? Can it be toxic, etc.? And then policy and regulation is also important, on which I will touch a bit later in more detail. So let's look now into some other considerations when combining these type of technologies. So the first one, how to adopt the technology with specific emphasis on your cultural perspectives. So one of the biggest hurdles in adopting new technologies, especially nanotechnology, is the acceptance from your community. In Africa, as we know, where traditions and communal values are deeply ingrained, the introduction of new type of science technologies can be met with skepticism and even resistance. So understanding these cultural perspectives is very important for successful adoptions. And for many African farmers, farming is not just an economic activity, but it is a way of life. And it's tied to cultural practices, spiritual beliefs, and community structures. And then when these new technologies, such as nanotechnologies, are being introduced, they can sometimes conflict with these long-standing traditions. So that is why it's so important to involve the local community in the process of developing such nanofertilizers right from the beginning, and even policymakers. Now, one effective approach is we can do is community-based participatory research, where local farmers are not just passive recipients of the technology, but they actively participate in the research and also development process, and they can also learn from this process as well. So this ensures that the technology is adapted to their local needs and their local context. Because if you design, for example, in the lab, a nanofertilizer for a greenhouse trial, this may not necessarily work in the field where the soil is different, there's different microbes, the weather is different, there's maybe other cultural practices that are being applied, and then it may not work as efficiently, sorry. So let's move on now to ethical considerations. This is also very, very important. As with all technological advancements come very important ethical considerations. So while nanotechnology is also very promising, it still raises concerns that need to be addressed to ensure its responsible development and application. This is very important, and there's kind of a lack of studies on this, and this is the environmental impact of the nanoparticles that constitute the nanofertilizer. Now, while the nanofertilizer can reduce the need for harmful chemicals, there's still a lack of knowledge to understand the real long-term effects of the nanoparticles on the wider ecosystem. Do they accumulate in the soil? How would they interact with other plants? Can they cause unforeseen damage in such an environment? And this is a question that researchers, as I mentioned, are still busy actively investigating. Now, another ethical consideration is also equitable access. How can we ensure that nanotechnology benefits all farmers, not just the large-scale commercial farmers? Now, smallholder farmers, who make up the majority of the agricultural workforce in Africa, they often lack access to the financial resources and infrastructure needed to adopt new technologies. And if we're not careful, nanotechnologies and other technologies could widen this gap between large and small farms and exacerbate existing inequalities. Then there's also the very important issue of bioprospecting. So as we develop these new type of technologies, we have to ensure that this indigenous knowledge and African knowledge is respected, and that local communities are properly compensated in some way for their contributions. And African farmers, as we know, they have a wealth of knowledge about their land, about their farming systems, and it's essential that they are recognized and rewarded for their role in such movements towards more sustainable agricultural innovations that include nanotechnologies. Now, let's look at the integration of indigenous knowledge and how can we integrate all of this. So one of the most exciting possibilities for African agriculture lies in the integration of indigenous knowledge systems or epistemologies with nanotechnology. This isn't about replacing the traditional practices with modern ones. It's more about combining the best of both worlds to create a more sustainable and resilient agricultural system. So indigenous knowledge systems, where the emphasis on ecological balance and community well-being, provide valuable insights that can guide the responsible development and application of nanotechnology. For example, traditional African practices such as intercropping and agroforestry can be enhanced by nanotechnology, which can improve the efficiency of inputs such as water, and nutrients. Another example could include where researchers work with local farmers to integrate nanotechnologies into traditional organic farming practices. For example, by using nanofertilizers alongside organic compost, farmers can be able to increase their yields without sacrificing the ecological benefits of organic farming. And this kind of hybrid approach represents the future of sustainable agriculture in Africa and other places also in the world, a future where traditional wisdom and cutting edge knowledge or technologies can really work hand in hand. So let's look at the benefits of combining traditional, indigenous, or African epistemologies and nanotechnologies. And this can bring, let's focus, for example, on enhanced sustainability. So, traditional knowledge, with its focus on ecological health, can help guide the responsible use of nanotechnology in agriculture. So, for example, by combining indigenous practices with nanotech, we can create farming systems that are more resilient and that are more sustainable. Increased resilience, we can also integrate, or rather the integration of traditional and modern methods can create farming systems that are better able to withstand shocks like climate change and pest outbreaks, especially when your nanopesticides are applied. Then cultural relevance solutions that reflect local knowledge and values are more likely to be accepted by communities and farmers, hence increasing the chances of the successful adoption of such novel technologies. And such a combined approach, by combining the epistemologies with the new technologies, this can also empower local farmers by valuing their knowledge and involving them in the innovation process rather than imposing external solutions that may not fit their specific context or their needs. Now, as with all technologies, there may be challenges in implementation. While we all know the benefits of integrating these two components, there remains, of course, challenges. And one of the biggest challenges still remains access to technologies. Um, Nanotechnologies require specialized equipment and expertise, which can be expensive and difficult to access, especially in rural areas. But this can all depend on the starting material that you use for manufacturing your nanofertilizer. For example, if you use green materials such as plants that are readily available, then you can actually lower that cost. Therefore, cost-benefit studies in this field are also very important. Another challenge is actually education and training. Farmers need to understand how to safely use and apply this nanotechnology. And this also requires then a significant investment in education and training programs. And this is where the government and NGOs and the private sector, they can all have an important role to play in to ensure that farmers have the knowledge and skills they need to take advantage of these new technologies. Now, cultural resistance is also another potential barrier that we've highlighted before. So some farmers may be hesitant to adopt new technologies that they don't fully understand or that they see as conflicting with their traditional practices. Overcoming this kind of resistance requires a deep understanding of the local culture and a commitment to working with rather than against local communities. Now, a nice example is in my master's study, I worked on avascular mycorrhizal fungi, and we were giving a presentation about the benefits of these types of fungi to a local previously disadvantaged community. And immediately when they heard the word fungus, they were thinking, no, this cannot be good. This is a dangerous thing to introduce into my agriculture. But once you explain the pros and the cons of these types of fungi and how to apply them successfully to promote plant growth in, for example, soils that have low phosphorus, they warmed up a bit to this technology. So education is very, very important, and open conversation to build trust with communities. Now, what other things or other important aspects one should consider here is also policy frameworks are also important for sustainable innovation. So to overcome these challenges, we obviously need policy frameworks that support sustainable innovation. Governments and policy stakeholders here play a key role, and they can create policies that encourages research and development in the nanotech field applied to agriculture, while also ensuring that these innovations are accessible to all farmers, especially smallholders. This is very important also is the regulation and standardization of how nanomaterials are manufactured. This is also very important to ensure that they are also used safely and responsibility. As with any type of technology, there is also a risk that nanoparticles could have unforeseen environmental impacts. So as I mentioned before, more robust research in this nanotoxicology field is important. For example, how can the application of nanofertilizers affect the health of workers working with it? Does it affect it? Does it not affect it? What is safe application method? If you, for example, develop a nanopesticide, how will it affect other beneficial microbes, for example, in your agricultural environment? And then policies should also ideally focus on supporting smallholder farmers by providing, for example, subsidies, access to credit, and as we mentioned before, very important training programs to help understand this technology, how it works, how the nanofertilizer is synthesized, how can it be safely applied, and what is the mechanism of action on the plant. Now, another important aspect is also collaborative research models. One of the most effective ways to ensure that nanotechnology benefits the African agriculture is through collaborative research models. And this should not only involve your material scientist or your physicist or your chemist or your nanotechnologist. It should also involve local farmers and policymakers right from the start of the discussions. So by working together, these stakeholders can co-create solutions that are both scientifically sound, but also culturally relevant. Now, for example, researchers can partner with a local farmer to develop a nanofertilizer that is especially designed for that region's unique soil or, for example, climate conditions. Or by involving farmers in such a research process, the scientists can create a product that meets the specific needs of that community. The community gains new knowledge on new technologies, and this can also increase the likelihood of adoption. Now, this type of participatory or kind of what people also, this is actually more applied in the climate research, but citizen type of science is here important. And this kind of participatory research model ensures that nanotechnology is not just imposed from the outside, but it's developed in collaboration with the communities who will actually be benefiting from this. Now let's look at impact, the impact this can all have on food security, which is very important in Africa. Now, the potential impact of nanotechnology on food security in Africa, this could be immense. So by increasing your yields, and for example, if you use plant materials that are agricultural waste, and by improving also the efficiency of your inputs, for example, your fertilizer, you apply less, you can apply it targeted to the leaf or the seed. This can help address some of the key challenges facing African agriculture. Now, in some African culture or countries rather, where food insecurity remains a major issue, nanotechnology could provide the solution by making farming more productive, more sustainable, because it's a small type of fertilizer, it's more readily taken up by plants, it has a higher nutrient efficiency, and research, as I mentioned before, has shown various benefits based on your plant physiology and growth. But then again, very importantly, this all depends on how your nanofertilizer is designed, the properties of the nanoparticles itself, and how they interact with your different plant physiological or morphological areas to promote uptake. Then, for example, also the use of nanofertilizers could help farmers increase their yields without relying on expensive and environmentally damaging chemical fertilizers. We've seen that sometimes farmers over-apply chemical fertilizers to increase the crop yield, but most of those fertilizers are lost in the soil. They leach into the water and cause eutrophication. And even more important, they can damage the soil microorganisms that are also important for sustaining plant growth. And yeah, this in turn could help reduce the costs of food production and improve access to more nutritious, affordable food for people. Now, besides all of this, as I also mentioned before, it's very important also, although this nano type of technologies like the nanofertilizers and nanopesticides may offer many benefits, again, it is very important to consider the environmental impacts. Again, here, safety testing in humans, in animals, in insects is very important. Because, for example, you can design a nanopesticide against a certain insect, but the effect it may have on other beneficial insects may be disastrous, which changes the whole ecological system. So then also let's look at what are the economic implications for farmers? So as we know, for many African farmers, the economic implications of adopting nanotechnology are a concern, okay? It may offers the potential to reduce input cost and increase yield, but the initial investment required to access it can be prohibitive, especially for your smallholder farmers. And again, to help with this, governments or NGOs or private companies, they can work together to create financing mechanisms that make nanotechnology accessible to all the farmers, not just large-scale commercial farms. And this could include potential subsidies, microfinance programs, or public-private partnerships that help farmers access the tools, and also very importantly, training they need to adopt these new technologies. Now, talking about training, the development of educational initiatives and knowledge transfer is also very important to make this system work. Education, as we all know, is critical to the successful adoption of new technologies such as nanotechnologies in African agriculture. Farmers need to understand how to use these technologies effectively, and this requires a significant investment in education, and training programs. In addition to training farmers, we also need to focus on knowledge transfer between researchers and communities. This is also very important. Open research. This means creating spaces for dialogue where farmers, scientists, and very importantly also policymakers can share knowledge and learn from one another. Particularly, this type of knowledge exchange should occur in the mother tongue. Then, for example, an educational initiative focused on nanotechnology can be introduced in, for example, agricultural training centers, already in schools, for example, also. Farmers can attend these workshops where they learn how nanotechnology can be safely applied to improve their crop yields and, for example, reduce water usage since you apply less of these things. And this kind of knowledge transfer is essential for ensuring that nanotechnology is used effectively, but also sustainability. So now, the role of the community is very, very important. This cannot happen if the community is not involved. The communities need, or the farming communities need to be involved in not only the research, but also the development, the training, and the adoption processes, so that we can ensure that these new technologies are relevant to the specific culture, it is adapted for the local environment, and it is more widely accepted. Now, here, NGOs can help play a key role in facilitating such type of engagement. They can act as a bridge between researchers and farmers, and also help to translate scientific innovations into practical solutions that meet the needs of local communities, right? For example, NGO can also partner with a researcher to introduce nanotechnology in organic farming practices. This is just an example. By engaging the community in the development process, this NGO can then be able to ensure that the technology is adapted to the local context and accepted by the farmer. Now, also another important point is technological accessibility and equity. And this is perhaps one of the biggest challenges facing the adoption of nanotechnology in Africa is this technological accessibility. Many of the smallholder farmers, especially in the rural areas, lack access to the infrastructure and financial resources needed to adopt to new technologies. And basically, to ensure that nanotechnology benefits all farmers, we have to focus on equity in technology access. This is very important. And this basically also aligns with creating policies and programs that make this type of technologies affordable and also accessible to smallholder farmers. Okay. Then, for example, governments can also introduce a program that provides the subsidies, as I already mentioned, to smallholder farmers who adopt this type of technology. That can also be very, very beneficial. Now, let's look at the future direction in research. We also mentioned already that more multi or interdisciplinary collaboration is very, very important. Several areas exist where further research is needed, for example, in your nanotoxicology, and actually find more fundamental research on how the nanofertilizers interact with the different components in your ecosystem, for example, the plants, the insects, the soil microbes, and also your pests and diseases. It's important for one research direction could be to contextualize nanotechnology for African ecosystems. So each region of Africa, sorry, has its own unique environmental type of conditions, and research should focus on developing technologies designed for that specific region. Also, the ethical and safe development of nanotechnologies or nanomaterials is very important, applied in agro-nano type of technology, and exploring type of indigenous knowledge in relation to modern technology is also very important. There's still much to learn from traditional African agricultural practices, and future research should focus ideally on how these practices can inform development of new technologies. That is why involving your social scientist in research is also very, very important. Not only focusing on the material and nanotechnology research, but making it more interdisciplinary and liaising with your farmers and your social scientists. So let's look at the government and the NGOs, what role they can play. They can also play an important role, as I've already mentioned, in adoption of the nanotechnology. They can create policies, as we already mentioned, and they can facilitate community engagement, education and training, and basically act as intermediaries between farmers and researchers. Now, one example that comes to mind can be For example, a partnership between the African Developmental Bank and local NGOs in several countries, which provide grants to smallholder farmers who can adopt these nanotechnology-based solutions. And this type of public-private partnership can be essential for scaling up the use of such nanotechnologies in African agriculture. Now, if we move on to funding mechanisms, to support the widespread adoption of nanotechnology, we need to develop sustainable funding mechanisms. And this can include public-private partnerships, international grants, or even local investments and research and development. For example, governments can dedicate special funds for developing nanotechnology research in agriculture, and this fund can provide, for example, grants or financial support to researchers and farmers who are working on innovative solutions that integrate nanotechnology with also traditional farming practices. Then again, cross-disciplinary collaborations, very important here between scientists, farmers, policymakers, and other stakeholders, because we have to remember agriculture is a very complex system, and solving the challenges it faces requires a holistic approach that draws on expertise from different types of field and also epistemologies. So, for example, more collaboration is needed between agronomists, nanotechnologists, and social scientists, as I've already highlighted, and this can help ensure that your new technologies are not only scientifically sound, but also culturally and socially relevant. So by working together, these experts can also co-create solutions that are both innovative and sustainable and accepted by the local community. So in conclusion, the integration of African epistemologies and nanotechnology in sustainable agriculture represents a powerful opportunity to address the pressing challenges of food security, environmental degradation, and economic inequality in Africa. By combining the best of traditional knowledge with cutting-edge technological innovations, we can create a more resilient and sustainable agricultural system that benefits the farmer, the ecosystem, and also the community. However, realizing this potential will require a concerted effort from governments, researchers, policymakers, farmers, and also communities. It will require policies that support sustainable innovation, funding mechanisms that make technology accessible to all, and collaborative research models that ensure new technologies are adapted to local contexts and local agricultural environments. And most importantly, it will require deep respect for the knowledge and wisdom that has sustained African agriculture for centuries. By honoring this knowledge and integrating it will this is important. By honoring this knowledge, this type of indigenous epistemology or indigenous knowledges with modern technology, we can essentially create a future where African agriculture is not only more productive, but it's more sustainable, it's also more resilient and just. Now, if I can move on briefly to digital technologies, I want to mention something about that also briefly. We still have a couple of minutes left. For example, nanotechnologies can also be integrated with digital technologies such as sensors and drones and the Internet of Things devices that can allow real-time monitoring of, for example, your soil health, your crop growth, and your environmental conditions. So by collecting and analyzing such data, these technologies can enable farmers to make informed decisions on when and also where to apply, for example, a nanofertilizer or a nanopesticide, hence to optimize their use and improve the crop yield. Machine learning, for example, algorithms can also be used, and this can be used to predict nutrient needs of a specific crop based on real-time data, providing farmers with a highly precise application schedule for nanofertilizers or nanopesticides. So, for example, by incorporating this type of digital technologies such as sensors and drones and smart irrigation, these can all be adapted to the African context by integrating indigenous knowledge, for example, of water conservation and soil fertility. Traditional farming techniques can be enhanced with data insights, ensuring that the knowledge passed down through generations is optimized for modern agricultural challenges, which is very important. Furthermore, by incorporating digital tools to monitor the long-term effects of nanofertilizer use on soil health, biodiversity, and water systems, farmers can maintain sustainable practices while optimizing crop yields. In addition, interestingly, blockchain technology can also be incorporated in this kind of nanotechnology African epistemology theme, and this can be used to ensure transparency and traceability in the use of these type of nanotechnologies such as nanofertilizers, nanosensors, nanopesticides, particularly in regions where trust in new technologies may be low. So by documenting every step of the agricultural process, from the application of the nanofertilizer to the monitoring of the crop health, the farmer can ensure that their practice again aligns with your sustainable indigenous farming philosophy. So in sum, by integrating all of this, we can create a powerful framework for sustainable agriculture during a time that agriculture are facing many challenges and that respects traditional knowledge while leveraging the best of modern science and technology. And this approach not only optimizes agricultural productivity, but also ensures that cultural values and ecological balances are maintained. I think that's all from me from the time being. Thank you so much for your attention.